Hi, everybody. Welcome to our webinar today, focused on what's new in drone reality capture for architecture, engineering, and construction professionals. Before we get started, I'd like to mention a few housekeeping notes. Today's webinar will be recorded. Slides and the recording will be made available to registrants shortly after the session. In concluding the presentation, there will be a Q&A session. We encourage you to ask questions throughout the webinar. So as you think of your question, please add them to the chat, the question window in the control panel. We will also have a series of polls, so we'd really greatly appreciate your participation. I now invite our speakers to turn on their cameras for introductions. Today, I'm joined by a number of imagery experts. I'll start with myself. My name is Kaylee Monjone. I'm a partner and manager on the imagery and remote sensing team here at Esri. And I actually joined Esri through the acquisition of the Sitescan product and team about 2 years ago. So I've been with the Sitescan product for nearly 5 years now. I also manage the relationships with our valued partners that we'll be talking about today. Next, I'd like to introduce Andrew Carey. Andrew is an account executive on the imagery and remote sensing team and is dedicated to supporting Esri's AEC sector solutions. He's a certified remote pilot. He has over 5 years of drone mapping experience supporting the survey and mapping industry. Next, we have Daniel Chantlos. Daniel is a solution engineer on the AEC team. He joined Esri from a civil engineering firm where he led a GIS team for several years on many projects. And today he works with our users to help them implement Esri technology and workflows. Last but not least, I'd like to introduce Brian Connolly. Brian, like Andrew and myself, he sits on the imagery and remote sensing team as a solution engineer. He has over 10 years of experience in the field of remote sensing, and today he works closely with our users interested in leveraging drone, LiDAR, and imagery workflows in Arcgis. For our webinar agenda today, there's going to be 4 main sections that we'll focus on. In the first section, Andrew is going to be reviewing a brief introduction of Sitescan, demonstrating how it works and shedding light on the types of data products it produces. The second section will cover Sitescan's new photogrammetric processing engine, SURE. We'll cover the capabilities of the new 3D mesh engine integration, particularly demonstrate the types of highly realistic models that it outputs. And then we'll hear from Daniel, who will overview how these 3D models can be used in GIS and CAD workflows. And finally, Brian will wrap things up by covering a partner success story, which will demo the combination of LiDAR and drone imagery. So I now invite you to participate in our first poll. You should see the poll question pop up on your screen here. The question is, how would you describe your organization's drone program objectives? So are your drone program objectives focused on documenting and keeping record of site conditions? Do you intend to mostly share your drone data with project managers and key stakeholders? Are you mostly or more focused on gaining insights on site condition data, such as volumetric measurements or extracting features, monitoring change? Perhaps you find value in drone data by using it for marketing and brand promotional purposes. And then lastly, maybe you have another initiative for what your drone program objective would be. So if you could please just select your response. I'm seeing a lot of answers coming in the chat, and click submit. Okay, I think that gives us enough time. We can now close the polls. Great, I'm seeing there's the majority of you are looking to leverage this drone data to utilize in taking measurements and analysis and monitor change and so forth. So it's really insightful. We appreciate your participation. Your feedback is helpful for us. Great. So next, I'm going to hand things off to Andrew, who will be telling you guys more about Sitescan.
Hey, thank you, Kaylee. Yeah, it's great to see that feedback coming in from the poll there. I see the majority of the attendees today are recognizing that the drone image collection workflow is a tool for us to collect quality data for us to really gain more information about a particular site to help us do our job. So I'm glad to see that almost 70% of the folks, or 69% of the folks here, are seeing that they want to calculate information out of their drone images. So great to see that. So I'm pleased to have the opportunity to provide here a brief introduction and background into Sitescan for ArcGIS. Sitescan for ArcGIS is an end-to-end drone cloud software solution. What does that really mean? The essentials of Sitescan have been built to support the field planning, data collection, data management, image processing, and sharing of drone aerial imagery to gain insights and new perspective intelligence into real site conditions. Collaborative drone imagery data from Sitescan for ArcGIS provides detailed aerial imagery as a system of record for organizations to collect and share data to a wide variety of users within their organization. Now, before I go too deeply into new features and workflows, I'd like to take a minute and review the primary products that Sitescan for ArcGIS produces. High-resolution orthomosaics, digital elevation models, 3D point clouds, and high-resolution reality textured 3D meshes can be generated for viewing and export. In addition to the products, Sitescan as a web manager has tools for detailed site examination, such as report generating, digital drawing and model comparison overlays. All this information can be interacted with directly through the web manager. One of the most exciting new features brought into Sitescan this year is the new enterprise fleet management capabilities. These program tracking features contained within the Sitescan web manager record and document drone programs' internal compliance standards. This could include examples like pre-flight checklists, flight location history, system maintenance, performance records, and pilot certification documents. All useful tools when managing a large and complex drone program. Sitescan for ArcGIS workflows can be broken up into 3 distinct steps. Step 1, field planning and image capture. This iOS mobile application has been built for the Apple iPad. It's built in a way to maximize image management capabilities, planning functions such as 3D mission setup and geospatial layer display. Step 2, image data loading and management. This cloud-based interface contained within Sitescan has all the permission and account details set up, as well as the image management and processing engines that produce the aerial intelligence. And step 3, data sharing, integration, and dissemination. This includes direct connections into core Esri software applications, as well as advanced image processing tools like raster functions and GeoAI. This includes automated image detection and feature extraction, as well as direct integrations to partner software portals such as Autodesk. Now, I'm going to go into a little bit more detail about each one of these steps and the basic workflow. I'd like to highlight in the following slides more key functions of these features that relate directly to the webinar. The Sitescan ArcGIS mobile application is built on the ArcGIS Runtime SDK, and it contains pre-flight template modes that have been built to optimize and capture drone imagery data that will produce the best results. The flight modes have intelligent collection parameters like camera angle, image overlap, terrain following, and dynamic shape and size considerations. In addition, other collection modes include Pano 360 photospheres, linear collections, and overfly restrictions that may be at a particular site. Along with the standard flight modes available within the mobile application, Sitescan for ArcGIS has direct connections to ArcGIS Online. This incorporated feature brings additional layers from existing GIS databases right into the field planning application. This allows project managers or planning parties to predetermine where and how flights will be flown to ensure that the proper data is collected. Step 2, this is focused on the cloud-based Sitescan web manager. Once everything is captured, it goes up to the Sitescan web manager. This is the interface where account and user permissions are set up and managed. but it's also been built to load imagery, ground control, and organize projects into meaningful and clear project folders that make sense for your organization. The Sitescan Web Manager has direct visualization and analysis tools such as distance measurements, volume calculations, and high-resolution inspection reporting. In addition to overlaying basic PDFs or DXF files to display immediate real-world conditions, the linking between more advanced models from Arcgis Online or BIM 360 means that complex models, drawings, and designs files can be draped over drone imagery for a more contextualized feedback experience. Because Sitescan for Arcgis has been designed as a drone imagery management tool, the direct sharing and collaboration buttons that take the generated product's usefulness further by making them available in downstream geospatial software applications. Step 3. As I saw from that first poll there, we're all concerned about how the data gets disseminated and moved into our organizations. So after the collection and data processing generation steps are done, the most impactful step begins, in my opinion. Sitescan for Arcgis has been built to directly interface with core Esri software solutions, making the experience seamless to display and incorporate imagery products into mobile applications, web apps, or geospatially oriented dashboards, along with advanced raster functions in the core Esri software. Sharing into Esri or Autodesk platforms is super simple and quick. Now, while that concludes my introduction primer into Sitescan for Arcgis and what it's capable of, I hope this background provided you guys with the beginning steps to understand the possibilities that drone imagery can begin to provide your organization. And with that part, I have poll question 2 popping up here. I'm going to set up for our audience. So really, it's a basic question. We want to engage with our attendees today to learn about the size of your programs, of those folks listening in today. And I'll let that poll cook for a minute, but I'll say that as the responses kind of are coming in, I'll take a moment and emphasize a recurring theme that I've seen throughout my years in the drone industry and how it relates to today's webinar. Really, no matter the drone program size, a consistent objective of aerial image collection programs is to establish digital information that creates insights and enhanced knowledge about a particular area of interest. I hope the upcoming presentations in today's webinar showcase further how drone imagery can be incorporated and shared throughout your Esri software ecosystem. The Sitescan application for ArcGIS represents the first step to collecting and producing high-quality results that make that possible. Okay, great. So I've let that go for a minute here. Looking like the majority of the folks are small operators, 1 to 5. That's in line with what I've seen over the last couple of years. Programs typically do start small. As data comes in and we begin to see the value that it provides an organization, they do grow. So, and I'm glad to also to see that there's almost 30% of the folks here are building the business case. So I do hope that the content provided in this webinar today helps folks articulate that possibility. So I'm going to close the application here, and I'm going to hand it back over to Kaylee. She's going to showcase a partner case study that really focuses on the new high-resolution 3D mesh engine Shore and what its possibilities are within Sitescan. So I'll pass it over to Kaylee.
Great, thank you so much, Andrew. That was really insightful. And again, I appreciate everyone's participation in the polls. So in this particular case study, I'd like to hone in on one of our newly established partnerships with the drone hardware provider Wingtra, as Andrew mentioned. And in teaming together with Wingtra, our partnership made it easy to demonstrate how to acquire real-world insights by leveraging our latest technologies together. So first, we captured imagery with the Wingtra 1 Gen 2 drone and the new oblique payload. And then we were able to process a city-scale data set using Sitescan with that data. And Sitescan is powered by our new Shore for ArcGIS meshing engine. And this incorporation of Shore is a recent and fundamental enhancement to Sitescan. In addition to high-resolution orthomosaics or DSMs and also point clouds, Sitescan now creates beautiful 3D meshes that can be analyzed directly in the Manager web application or published to ArcGIS Pro, ArcGIS Online, or in an enterprise portal. More about this use case, the area captured, it covered over 2,000 acres of Zurich's city center in Switzerland, and it outputted a resolution of around 3.1 centimeters or 1.2 inches. Perhaps one of the most powerful takeaways from this case study is the fact that the Wingtra 1 drone, it was able to collect the imagery in about under 6 hours, while the data was able to be uploaded and processed into the Sitescan Manager in just under 24 hours. Sitescan enables a new level of reality capture workflow that allows their users to digitalize their environment and enhance the system of record using drone technology. If you're interested in learning more about this use case, you can view the blog post that we've shared in the chat here. So again, we invite you to participate in another poll. As it pops up on your screen here, this question, short and simple, if you are using an existing drone processing software, please select the option. You might be using several. You might be, as we saw the polls in Andrew's poll he just asked, some of you are still prospecting, looking for an option, but would love to have your feedback, whether it's an Esri Sitescan or drone to map solution, our partner Pix4D, drone deploy, propeller, or other. Great, so I'm seeing a lot of results coming in the poll. We'll give it just a few more seconds here. All right, we can now close the poll. And it looks like there's actually quite a few of you, just 37%, the majority using the Esri technology, but almost the same amount of you are using, as I mentioned, our partner solution, Pix4D. I'd be really curious to know what these others are. So maybe there'll be opportunity for us in the near future to have those discussions with you guys. So again, your feedback's really helpful. Thank you. Thank you again for participating. So I now would like to hand and transition things off to Daniel. He's going to demonstrate further the value of achieving a digital twin in GIS and CAD environments.
Thanks for that. Great presentation, Andrew and Kaylee both. Today I'd like to switch things up. Now, a great value proposition of becoming a Sitescan user, or if you're already an Esri user, is the seamless data integration between Sitescan and Esri products, as well as our existing and new connections with our exciting partnership and alliance with Autodesk to bring in BIM 360 data into your GIS design. Along with all that Sitescan data. So today I'd like to present a story map, and I'm going to share my screen real quick. All right. So as I said, we're going to be showing a story map today for a new building project here on the Esri Redlands campus. Now, throughout this building project, you'll see a lot of data integration from Sitescan, GIS data, and as well as some Autodesk data. So let's dive right in. So at the heart of a story map is being able to provide you with map-based storytelling tools that bring everything from multimedia, simple text, photos, as well as our GIS applications that you can build directly in the Esri environment and system of engagement. So right here, this building project story, we want to start with a public engagement phase. Now, this is just going to be a brief description of the project that we are describing today that we want to bring to life in Redlands with this new building E, this 110 square foot state-of-the-art building that we'll be exploring throughout this project story. So right away, what you see here is a 3D scene. And I will be touching more on this, on the 3D scene capabilities later in this story map, but we want to give our investors and stakeholders and project team and the public what the current state of our campus is today. Now we could show that through these very simple 3D multi-patch buildings as well as vegetation. And what we'll be exploring later is more, maybe even bring in the interior space of these buildings with ArcGIS indoors to give greater context to the size of these buildings and the contents of these buildings and where our employees are going to be working and at this campus in Redlands. So as we move along in this project story, we've now got a great sense of where this campus is and how many buildings we currently have. Now, also great capabilities of story maps is being able to bring in dynamic quotes. Maybe we want to describe Esri further, and we also want to bring in more multimedia and photos to really create a story of what this campus looks like from the ground without actually visiting it. Now, along with that, building is a pretty big investment, and we want to attract new people to this environment, to this campus. So a great storytelling capability that's built into the ArcGIS Story Maps platform is being able to build a map without actually any feature services. In this case, we're going to create a guided tour of Redlands. So right away, we're showing where Building E is proposed. Maybe we want to showcase where some shops are, where people will want to shop, maybe some entertainment, in this case, an amphitheater, or even on this next one, a golf course. These are all built into the story map telling phase, and you don't need any feature services. You're not even using web maps at this point. But speaking of web maps, here's where we start to talk about the planning and design phase now that we've gotten public engagement through this part of the story. Now, AECs, if you're familiar, they need to have geospatial context. They need to be able to showcase that they understand the environment where these buildings are going in. And as a Sitescan user and an Esri user, you're able to automatically streamline your Sitescan orthomosaics in this case into a web map. Now, what we're looking at here are actually 3 proposed locations where this building may go in this scenario. Now we're going to key in on one specific area, and what you can see in the feasibility stage, you need to be able to showcase your utilities. These can come from your CAD design team, proposed utilities. It can also come from the utility providers as well as public data. So what we're looking at here on this building site is the actual utilities for this new building, but as well as understanding where the utilities are, we also need to understand maybe where schools are and also parks and land use and zoning. And as an AEC, this really shows that you've done your homework on this site, and combining it with Sitescan just gives greater context to this new building and this story. So web maps are essential in the Esri environment. Now also along in the story map, we can now begin the planning and design phase of actually being able to attach the building footprints and building floor plans, these PDFs. We're just simply attaching them to the story map to give our investors and stakeholders and public greater understanding of this project. So as we move through the planning and design phase, we actually begin construction. And if you're already a Sitescan user, you may be aware of using a time slider to be able to compare the beginning of your construction all the way through the end of construction. You can do just the same in story maps. You can embed your Sitescan orthomosaics along with our Esri base maps to give greater geospatial context of your construction site. Now, I'd also like to talk about construction monitoring. And for this, we're actually going to be talking about a few other Esri products that you may be aware of as an Esri user. And if you're not, we'll be covering those here. So what we're looking at is a dashboard. Now, dashboards have become a hot topic over the past year and a half with COVID especially. We've seen dashboards everywhere showing statistics and dynamic elements that are visually compelling. And the purpose of a dashboard is to give you that information quicker than you can just looking at a map or looking at some printed PDFs. So for this building, I'm actually going to zoom in. And when I zoom in, you can see that we've got our orthomosaic directly from Sitescan embedded into a web map, as you saw earlier. Now, in this case, this is actually the construction phase. So we're bringing in elements from our CAD design team, as well as our GIS team. So here we have the structural foundation of our new building, as well as some very important elements that we'd like to monitor the actual construction workforce as they're out on the site. We have features such as the trenching of our building. As you saw earlier, it's important to know where your utilities are. So the trenching that you see here is new trench in order to tap into those existing utilities that are actually going to bring life to this structure and connect it with the environment around it. We also have these yellow polygons for laydown areas, as well as red polygons for areas that we really don't want our workforce to be having boots on the ground in these locations. These are areas where there could be some safety concerns at the job site. So as I mentioned earlier, what we're bringing into this dashboard is all these features to give visual context, but we also need a work assignment system, which we'll be talking about. Arcgis Workforce is a product that is basically a to-do list. Your dispatcher back at the office can assign work assignments to your construction crew, and those assignments will be completed on the site, and you can view that all in real time here. So what we're looking at in this case are trench inspections. So as I mentioned earlier, we have that trench that helps connect our new building to existing utilities. So here right away, we can see the status of our trench inspections that are assigned through Workforce, as well as these dynamic dashboard elements that show where the trench has not been filled and where the trench has been filled. This is just a very simple, quick visual analysis of our current state of the job. Now, also workforce assignments, we have, it's a point-based assignment system, as we have here on the trench. We've got a couple of assignments. And here we can see some completed assignments where we had a construction worker go and check for exposed utilities before the trench is filled back in. We need to make sure that the utilities are all connected and everything looks good before we go and bury them to connect to the other utilities. We can view them by priority, as you see down here, our work assignments that are low, medium, high, and critical priority. This is all valuable information that the dispatcher and who has access to this dashboard can view in real time. Now, as I mentioned earlier, we have these red polygons. Behind ArcGIS Workforce is another product called ArcGIS Tracker. Now, this can track your construction crew with boots on the ground in real time using the GPS of their mobile devices, which ArcGIS Workforce is once again a mobile solution for your field crew. So this is our construction monitoring phase of the project. Now, as we are constructing the building, we're flying with Sitescan to create these great meshes using the Sure processing engine behind Sitescan. So we're able to also embed those meshes into our story map, as you can see here, to view the current status and construction of the building. Those meshes that are generated from Sitescan are brought directly into our story map. So along with our 3D tools while we're constructing this building, we're able to embed our scene viewer from ArcGIS Online or ArcGIS Enterprise directly into our story map. And if you know anything about our scene viewer, it's got a lot of great capabilities that we'll cover today. So one other data output from Sitescan, which I haven't talked about on the story map, is actually our LiDAR, our point cloud from our orthomosaic, our flight from Sitescan. We can bring that into our scene viewer along with the 3D mesh and the 2D elements that you saw earlier. Now, the scene viewer is capable of showing your true color point cloud, as well as an elevation point cloud, and even a classified point cloud, which we'll touch on here. So with the scene viewer, we're able to have our keyframes of our campus, and I'll switch back to the overview of our campus here. So the overview of the campus really shows those 2D elements. Here we have our building footprints extruded into 3D shells to provide greater geospatial context. We have our Sitescan orthomosaic on the ground, and then we also have, through our Autodesk Alliance, the ability to read Revit models that we can combine with all of that other rich context and data together into our scene viewer that you see here. Now, the Revit model is the design model from our design team. So we can bring that in to actually view what the project would look like at its constructed phase without the project being constructed. And we can also use the scene viewer to fly to different areas of the project to view different angles without having boots on the ground, without actually visiting the site. We can view this from the ground along with our other buildings, and right away another feature shows up that I'd like to discuss. The vegetation that you see here, these trees, using the Sitescan point cloud, we can actually talk about another Esri solution called our 3D base map solution. This will take that classified point cloud and extract your vegetation layers or building layers and create 3D objects from those. So we're able to extract the vegetation classification and then create trees that we can use in our scene to provide greater context for our viewers. Now, as we mentioned earlier, we also talk about utilities. Now, we view those utilities in 2D, and that's great and all. That's been done many different times. But what we can do now is actually view those utilities in 3D beneath the surface. So here we have our utilities, and it's just a tad slow, but these utilities are just beneath the surface, and we can really examine where they're going to connect to the building below the ground to provide that greater context to the entire building project story. Also, the last application I'd like to talk to you today is an application that really combines your design data with your reality capture data from Sitescan. And that's this application here. This application, as you can see, we've got the Revit model of this new building along with our mesh created from Sitescan. Now, once this mesh loads, we're able to visually see the contrast of what the designed Revit model is compared to the reality capture. And maybe some elements changed. Maybe the solar panels had to change the placement on the roof structure. Just going to open this in a separate tab for viewing. Should load very quickly. Because another great feature of this application is being able to load all of your existing drone meshes to view them from the beginning of the project lifecycle all the way through the end of the construction lifecycle. So while this is loading here, we're going to turn off the Revit model and let's go back to the beginning of this construction. Very quickly, the Sitescan orthomesh loads, and we can view this by different months to see the different construction phases of the project that were captured through Sitescan that we're viewing in our Scene Viewer application in the ArcGIS environment. Now, if we skip ahead, we can see the foundation has been laid, and we can go through this all the way to the very end. So we'll go ahead and go to the final constructed phase of this. And once again, we'll load in our Revit models. And what we have here is actually a building slicer tool. I'm going to turn off this mesh. Our Scene Viewer has these great widgets that allow for great 3D analysis. So what we can do is we can dynamically slice directly into the building. We can view the different sections of the building. We can view different floors one by one, very easily and directly and dynamically. We can view different construction phases from one all the way through the very end. We can spin this around. And also what's great about this is being able to show the different teams that are involved through this construction life cycle, the different elements that they help design for this building, as well as all those different reality capture flights that you captured through Sitescan. So we have a lot of great resources about story maps online, how you can learn more about it. We have our user conference videos about story maps. So I really just wanted to present to you today this great building project story that takes you all the way through the public engagement phase to the planning and design phase, through the construction monitoring phase, all the way through 3D analysis that's available. So with that being said, I'd like to hand this back to Andrew to present another poll question.
Hey Dan, thank you so much. I mean, it's absolutely fantastic to showcase how drone imagery really is part of a bigger puzzle with all this other modeling and drawing and design. Sometimes as drone operators, we can get into our little bubble. We can perform our volumetric analysis, do our distance measurement, build a topo, but within our organizations, the imagery and the high resolution meshes can provide value to other folks telling other stories about a particular project. So I love how it all comes together in your example. So I'm pleased that, thank you so much for showing that. And I'm gonna now move over to a third poll for everybody. And this poll question is really related to hardware being considered or utilized by your organization. We are all familiar with the behemoth of DJI in the industry, and it does seem to be reflecting in that poll responses there. So looking like we do have a good 20% hold on the other. So any other candidates, I'd love to get your feedback on the hardware that you're using, maybe in the chat or question window. If you could put your manufacturer, it's always great for us to know what's coming online and what's being utilized by the industry. So appreciate that feedback, everybody. I'll ask the moderator to close the poll up there. And with that, I'm going to lead us into Brian Conley and our final and wrap up story here about some partner data and some integration of the LiDAR data with some imagery-oriented image catalogs, and pass it over to Brian. Brian, take it away.
Thanks, Andrew. Yeah, that was a really great demo, Daniel. It was really nice to see what we can do with drone imagery and story maps and dashboards. I'm actually going to switch gears just a little bit, but continue that same kind of conversation here. We're going to talk about a partner story example where we were able to combine drone data with LiDAR data into a complete reality capture inspection experience, all in a web environment, similar to what Daniel showed. I saw some questions in the chat about LiDAR, and despite the fact that Sitescan can't process LiDAR, we can integrate LiDAR using our other ArcGIS products like ArcGIS Pro. So I'll show some of that today. Regal recently constructed a new headquarters for their US operations, and we partnered with them to showcase their LiDAR acquisition capabilities, along with ArcGIS through the use and integration of dashboards, hosted 3D point clouds, ArcGIS Image for ArcGIS Online and field apps, and I'll get into all of this in just a moment. For those of you who are unfamiliar with Regal, they are a top LiDAR manufacturing company and Esri partner. They manufacture LiDAR sensors for aerial, drone, terrestrial, mobile, and even bathymetric platforms. Over the course of construction of their new headquarters in the US, their teams collected LiDAR from each of their available platforms, and they provided these data to us so that we can help build similar web applications to what Daniel showed, but combining both drone and LiDAR capabilities. So we combined their LiDAR with their reality capture from drone images from Sitescan and hosted the data in ArcGIS Online, and that allowed us to create a web experience to perform inspections from the office, update fields or update crews in the field, and help managers visualize and track progress during each project phase. So over the next few minutes, I'll show the results of our effort. But first, I just want to thank Regal for providing these incredible point clouds for us to showcase today. So just bear with me here as I set up my screen. Okay, we're going to start here with the imagery base map in ArcGIS Online. When I turn on the drone imagery processing, used Sitescan for ArcGIS, we can see a few examples of the orthomosaics that were produced in Sitescan for ArcGIS. Using the drone imagery, we can visualize the change on the construction site. Moving into the LiDAR point cloud, first visualized and rendered with elevation data so that cool colors represent low elevation and warm colors represent high elevation. And using a 3D scene like this, we get an incredible realistic perspective of the project area. This point cloud is published to ArcGIS Online as a scene layer package. And so we're able to stream the points all over the web using ArcGIS Online. We classified the point cloud in ArcGIS Pro using our point cloud classification tools, both automated and deep learning methods. And with a classified point cloud, we can begin to extract features, create terrain models, and remove unnecessary points from view for a much cleaner experience. Filtering the points to just view the building points gives us a really great perspective on how we can work with these data. Regal also collected imagery along with its LiDAR acquisition, providing a completely colorized LiDAR point cloud for a realistic view. Those of us not used to working with point cloud data often find it easier to understand a colorized point cloud like this. And I like to see all the people working on site within the point cloud. I'll use our measurement tools to get a quick measurement using the point cloud. And this gives us a really nice way to get a precise measurement in view. So I'll just take a quick measurement of this building entryway. And since my team likes to work in feet, I'll go ahead and switch to units. We can do more with this though, and we can enhance this experience by leveraging the raw drone images using oriented image catalogs. Oriented image catalogs allow us to bring in imagery alongside our point cloud. So I'll go ahead and load one in now. Just by clicking anywhere on the point cloud, it brings up that raw drone imagery collected for that spot. This allows us to inspect changes on site and make better decisions by using the high-resolution drone image capture data. You can see the footprint and orientation on the point cloud. For this project, Regal was able to collect more than just drone imagery. Their terrestrial and mobile platforms also collected high-resolution panoramic images. These not only helped us colorize the point clouds, but also provided a unique perspective for the sides and even the interior of the building. Oriented image catalogs are a great way to not only leverage your drone data, but also your 360-degree cameras, your panoramic images, and even video collections. These powerful tools can be combined on the web for a unique inspection experience, allowing for project managers and field crews to stay up to date with project status. Let's take a look at a dashboard that we helped create to inform field crew of potential issues on site. We'll first bring in drone imagery published as dynamic image layers using a new way to host image services, We call it ArcGIS Image for ArcGIS Online. This time lapse was able to visualize each project phase. So next, heading over to 3D, I'll turn on a layer so that we can begin to add inspection points for field crews. You can see the attributes on the existing data that is there, and we could add new ones using the editor tool. Directly within the web scene, I'll add a new task for a worker to take care of that I need done. So let's go ahead and have somebody move this dumpster out of the way. I'll give it a title and a date, and this will inform my field crew on what they need to do today. With their tasks assigned, they can complete the job and immediately update office crew when their work is done. Project managers can visualize tasks and filter them by priority or status, or wherever you set up your dashboard. Collaboration like this has never been easier between field and office crew. And similar to how Daniel showed how Autodesk products can be brought in, I'm going to turn on the Revit model, which can be used to assess as-built and design data. So within the web scene, we can filter the Revit model for structural information or electrical or other utilities. And this gives us the ability to immediately work with this data, this 3D data in our web scene. But what I was really impressed with was how well the LiDAR data aligned with the Revit model. I'm going to use the slice tool so I can go inside the building. This allows me to navigate easily, but also allows me to intersect and work with specific layers at a time. Because Regal collected interior LiDAR as well, using their terrestrial LiDAR scanners, we could see the activity going on in the building. I'll wrap up by just taking a quick measurement of this door frame. And so with the power of ArcGIS, combined with both drone and LiDAR data, we're able to create an incredible web experience to help keep all our stakeholders and project staff informed. And with that, I'll pass it back to Andrew.
Thanks, Brian. Fantastic data set there from our partners at Regal. It goes along with the themes of today's webinar, which really are showcasing how this remotely sensed data can be shared with an organization and gain that intelligence associated with remotely collected data and how it all comes together. So let me make sure my screen is being shared here, and we're just about approaching our Q&A session of today's presentation. Yes, we are. So Kaylee, I'm going to pass it back to you for moderating the end of the Q&A. There's some contact information there for Kaylee and myself if folks have additional questions or would like to reach out. I also want to encourage folks to take a look at our upcoming Esri Imagery Summit, which will be an in-person event hosted at the Esri campus in Redlands in October. There should be a link in the chat session if folks want to get registered to attend. We look forward to having opportunities to meet and continuing the conversation with everybody today and investigating further how drone imagery can help solve your particular challenges.
Awesome. Thanks, Andrew, and thanks, Brian. That was a really powerful and cool demo as well. So I invite all my colleagues to turn on their cameras or turn them back on, Andrew, Daniel, and Brian. And actually, the Q&A will also be supported today by the Sitescan product manager here at Esri, Nico Bonafou. So he'll be joining us as well, and we can run through some of these questions. Looks like we have a lot of great engagement. I'll start with one of the first questions that came in early on. A question around the Sitescan flight application in trying, the user was wondering if it's available on Apple, so Android versus iOS. And I can defer to my team to answer.
So
yeah, I can jump in on that. So the Sitescan Flight app is an iPad-only application. So to use the Sitescan Flight app, you would need an iPad, but to use Sitescan as a whole and to process images in Sitescan Manager, you're not required to use the Sitescan Flight app. So you can capture images using the drone manufacturer's native app, like the DJI applications, for example, or the Wingtra application, and upload those images to Sitescan Manager for processing.
Great, thank you, Nico. So I also saw some questions coming in, quite a few somewhat similar questions here. Leonardo, Dan, and Sean were asking, what is the main difference between the Sitescan and drone to map, and questions around understanding if Sitescan will replace drone to map.
Yeah, I can take that one. So Sitescan is not going to be replacing drone to map. The primary difference is Sitescan is a cloud-based software solution. So we're leveraging the processing power and cloud resources to accomplish the processing parts of a drone software solution. Drone to map is really a local processing solution. So it's relying upon the resources of the CPU within your organization. I've seen folks that don't have necessarily large CPUs at their facility, and it can be a bear when it's consuming those resources to process that imagery. So, but there are certain circumstances when you're disconnected from the cloud or you have a security limitation where you cannot connect to the cloud, and that's where drone to map is a really good alternative. We have seen the majority of our folks really opt to a cloud resource to process a bit more efficiently and quickly, and leverage all those sharing integrations of the tools. Hope that helps.
Great, thank you so much, Andrew. Next question coming in from Kaylin early on as well, and this is, I'm going to kind of merge two questions again together. So this is around the flight application. So if we fly using a DJI Phantom RTK and we were able to use the DJI app for the flight planning, will this affect the upload to Sitescan? And then, like I said, the second kind of question that somewhat relates to that, can the Sitescan fleet management capabilities import recording flight data from other flight applications like DJI Go, useful for tracking pilots' hours, currency, etc.?
Yeah, I can jump in. So the enterprise fleet management functionalities in Sitescan were released this July at the user conference. So today it's only logging flights that you perform with the flight app, and it's doing that completely automatically. We are about to release the ability to manually log flights that were performed outside of Sitescan, as well as the ability to batch import any fleet management information you already have. So that should be out late this, sorry, we're not in October yet, late October. It's in beta right now. So if you're an existing Sitescan user and that's something you'd like to try out, reach out to us. We'd be happy to let you try it out.
Thanks, Nico.
The Phantom 4 RTK part of that question. So the Sitescan mobile application is compatible with the Phantom 4 RTK. So it is possible to integrate your real-time correction, your VRS, your correction services can be your email, password, mount point, all that stuff can be inputted directly into Sitescan for use with the Phantom 4 RTK. I believe that was the first part of the question, but
yes, I merged two together. It was kind of all around the just general using external flight applications with our product. Why don't we look at, there was a LiDAR-based question around, can we upload LAS files into Sitescan?
I could take this one. No, currently we cannot work with LiDAR data in Sitescan, but a lot of our work with LiDAR data comes directly in Arcgis Pro, where we have not only really great LiDAR management capabilities, but some classification algorithms that allow us to basically classify everything that I showed today, some from buildings, roadways, utilities, ground and trees, and so on. And then you could publish that data as a scene layer package to Arcgis Online, so you could share it out to your organization.
Thank you, Brian. Another question coming in, how does one convert 2D building footprint polygons into 3D polygons for use in Story Map and ArcGIS Urban?
I could take this one again, unless Daniel, you want to as well. But as Daniel mentioned, it's our ArcGIS solutions for our 3D base map. It's a task-based workflow that takes you through the entire step from creating LAS data sets, as they're called, to manage the LiDAR, classifying your point cloud, then creating building footprints, and then 3D enabling those building footprints. It's a really great workflow. We have had multiple workshops on those, so if you're interested in those, please reach out and we can make sure that you can get access to some of that content.
Thanks, Brian. All right, looks like we have a Lance question coming in, or Lance authorization. So from Ryan, when will Sitescan have the Lance authorizations and not have the use of the third-party authorizations?
Sitescan does have the ability to request Lance authorization directly within the Flight app. So Lance is a system in the United States to obtain airspace authorizations for areas that require approval from air traffic control. And so that the Flight app, when used in the US, will let you know when you're in controlled airspace through an integration with our partner Airspace Link, and allows you to request and receive airspace authorizations directly from the Flight app.
Thanks, Nico.
Yeah, and I think part of that question about a third party part of it, I believe the FAA requires there's only a handful of authorized Lance providers, and I don't believe Esri is pursuing that individual certification with the FAA. So the third party part of it, Nico, I don't think there's any effort to eliminate an approved FAA third party, right?
I mean, no, it works great as it is with our partner Airspace Link. So that's how it's set up, and that's how it's working. Yeah.
Great. It looks like we have time for just about one more question before we wrap things up here. I was going to ask a question coming in from Peter. Can you compare processing time needed by Sitescan and Drone to Map?
I can jump in. I mean, it's a tough question to answer. So Drone to Map is desktop based, so the processing time will vary greatly depending on your computer's hardware. So it's really hard to say what your processing times might be there. And then processing times vary based on number of images, the type of capture, whether it's nadir imagery, straight down images, or oblique imagery, the resolution of the images, and a lot of factors. So can't really give you a number when it comes to Drone to Map, but in Sitescan, it's a rule of thumb. Again, the same factors will affect processing time. Rule of thumb is about an hour per 150 images. It's mostly linear, but yeah, that's assuming your standard, DJI Phantom 4 image around 20 megapixels. But yeah, it varies.
Just to add to that, Nico, I concur. It's hard to compare, right? I've processed multiple jobs in both Sitescan and Drone to Map. I don't have the statistics in front of me, but one thing that is the benefit of using Sitescan is that because it's all cloud-based, I was able to go do other things using my computer at the time. Where if it's Drone to Map, I have to wait for it to process to really be productive elsewhere. It's a big point.
Correct. And with when you're using desktop software to process your data, you're processing one mission at a time. Whereas with Sitescan, you could throw 10, 20 missions that you flew throughout the day, come back to the office, upload it all, and they'll all run in parallel. Sitescan will just spin up new servers to process each mission side by side. And so you're not limited by your local hardware.
Awesome. Thanks so much, guys. So looks like we've run up on time here, and that concludes our webinar today. As Andrew mentioned, if you see things or heard things that are of interest to you today, we're going to have a lot more content like this at the Imagery Summit, which is will be held live in Redlands, California, in our headquarter location on October 19th and 20th. So please, if you're available, we'd love to see you. You can find the link to the Imagery Summit in the chat window. As you saw, Andrew, and my email is shared as well on the screen here. Please feel free to reach out to us if you have any other questions. And we really appreciate everyone's participation and engagement today. There's a lot of great questions and a lot I know that we unfortunately didn't even have time to get to. So appreciate it. Thank you so much, presenters, attendees. Take care and have a great rest of your day.